We're going to get started. Can everybody please find a seat? The theme tonight is at least one step removed from commercial applications and maybe verging on architecture astronaut stuff. If you want a hands-on voice agent building experience, there's a workshop at the AI Loft, the AWS AI Loft. I think they changed the name from the Startup Loft here on Tuesday with engineers from AWS and DeepGram and Pipecat. So if you want to write some code, show up on Tuesday. Nina will post various things on social. And I think that's all of the logistics stuff. For those of you who don't know me, I'm Quinn. I work at a company called Daily. We make infrastructure and developer tools for real-time audio and video and AI. And I work on an open source framework called Pipecat that a lot of you in this room use. Today I'm going to talk about 9 newish patterns for real-time agents, some of which we are actually starting to use pretty widely in production and some of which are totally speculative. I'm going to talk for a few minutes and we have a great panel to expand on these ideas better than I can. There's a backstory to this talk, which I'll get to in just a minute. But first, for links to the panel and for the slides, because later I'm going to show some slides that have like really small type on them. If you want to actually look at the slides so you can read them, you can go to get.ai/new. Okay, backstory. So a long time ago, and for reasons that are going to be obvious in a minute, I'm trying really hard not to say in a galaxy far away, I used to plug a serial cable into the RS-232 port on the back of my Intel 286 PC. And I'd plug the other end into a modem that looked exactly like this. Google Images is great. And I would dial into a phone number that connected to another modem that was hooked up to probably a 486 PC, sitting under the desk of a forward-thinking IT person at a newspaper in North Carolina called the Raleigh News and Observer. That computer ran what's called a bulletin board system, which was a kind of forerunner to CompuServe and AOL and eventually the web. There were a lot of things you could do on the BBS. I'm sure I got access to it originally because I needed to write some paper for school and I was supposed to look at the newspaper archives. But I really have no memory of that because there were games on the BBS. And the best game, I thought, was called Trade Wars 2002. So Trade Wars was this big multiplayer world where you could explore, you could form teams, you could try to build up resource bases, you could fight, you could just hang out and chat. It was my first exposure to what an online world could be. I made a lot of friends in Trade Wars with people I had nothing in common with except that we had a PC, a modem, and knew the phone number to the BBS. And Trade Wars was totally text-based. And I've been thinking a lot about Trade Wars because all of us are back in a kind of retro future moment where we spend a lot more time in terminals and CLIs than we used to, which I'm very happy about. And Trade Wars was like an extremely manual experience in the literal etymological sense of the term. You used your hands to do single character commands or type stuff. You probably had a notebook sitting next to the keyboard where you like wrote down where the good ports were and where you could park safely at night. But, you know, you had a computer, so you could do all kinds of hacky automation stuff. This was a wrapper for the terminal interface to Trade Wars that helped you build and remember the universe map. This is a full-on graphical client. You could script the whole game with this completely separate, not quite freeware. I think I paid $5 for this or something like this, graphical client. So you could build these like trade loops and try to, you know, get a little bit ahead of your friends in the game. So I started thinking pretty early on when we were building voice agents, like right after GPT-4 came out, like what would a Trade Wars-like experience with an LLM driving everything feel like? What if flying around in that ship, you were actually talking to it like the computer in Star Trek, but like snarkier and more proactive? So a few weeks ago, I started asking Claude to like write bits and pieces of code for that experience, that Trade Wars plus an LLM. And here's what it looks like today.
aboard Space Pirate John. We're in Sector 0, the bustling heart of the galaxy, ready to make some cosmic waves or just a pit stop at the galactic ATM. What's the plan, Captain?
So what's all this about? It's my first time here.
Ah, a fresh recruit. We're playing Radiant Bank, a space trading game. You pilot a ship, explore sectors, buy low and sell high at ports, and try not to get blown up. Your current mission, should you choose to accept it, is to get rich or die space trying.
Well, that sounds great. Why don't we check out what's over in Sector 581?
Sector 581, excellent choice. It's one hop away. I'll get us going, just remember one jump at a time is the space lock. We made it to Sector 581. Looks like a great place to sell, with a port that buys all three of our commodities, ready to make some credits.
So that's a Cartesia voice and Gemini 2.5 Flash. Actually, it's a bunch of Gemini 2.5 Flash, which I'll come back to in a minute. My original goals for this side project were basically just to experiment with a few things. So first, LLMs are now really good at writing code, but I'm not very good at using LLMs to write code, or I wasn't a few months ago. I'm a lot better at it now. And when you're writing production code, at least when I'm writing production code, it's really hard to sort of climb up a very new tooling learning curve. So this was like an environment where I could force myself to have the LLM write all the code, which is really interesting, and would love to compare notes with all of you about that later. Second, I'm, as a lot of you in this room know, obsessed with experimenting with voice interfaces and multimodal interfaces built on a voice foundation. My intuition was that this kind of environment would be like really fruitful for that kind of experimentation. That has definitely been true. Like, it's been a kind of mind expanding thing for me to have this open canvas. And third, once you start thinking about having like this AI co-pilot in the ship with you, it's an entry point to thinking about long-running agent processes. And definitely 2025 is the year a lot of us are thinking about long-running agents from a whole bunch of different directions. And this has been a fun way to sort of think about that differently from the enterprise voice agent stuff I do for my day job. So with that context, it's probably not terribly surprising that this thing has gotten completely out of hand and broken side project containment. So for example, here's the trading interface, which is driven by the LLM in the voice agent. Everything you see on screen is sort of delivered in a format that is LLM controllable. I'll talk more about that. I didn't say that very well.
Can you show me the port details here, please?
Switching to the trade console. We're at the SSS port in Sector 0. It's selling all three: quantum foam at 24, retroorganics at 9, and neurosymbolics at 38. Ready to spend some credits?
Yes, buy as many retroorganics as I can afford, please.
Initiating a task to fill your holds? We'll scoop up as many retroorganics as your credits allow, or until your 30 cargo holds are full. Let's see how much organic goodness we can cram in. That's 30 units of retroorganics secured. Your cargo holds are full, and you've got 4,352 credits.
So we're lobbing lots of structured data from the LLM over the network to the client and dynamically rendering a lot of the UI. And the more of that we do, the more of that we think we should be doing. And so we keep going down this rabbit hole of trying to make the UI more dynamic instead of like making the game more playable. But that's, I'm sure, not an unfamiliar thing to all of you.
Let's hop over to Sector 5.
And here's interaction between a couple players.
Sector 581, home sweet home. Or, just another sector with no port. Warp power is at 196.
Oh, I just got a message from Trader P. Does he want?
Trader P says, "Greetings, Space Pirate John. I seem to have runcom. I guess they hit the send button too soon. What do you think they ran out of?"
I don't know. Send him a message asking what he needs.
Message sent. Hope we can help them out. Stranded pilots are a cosmic buzzkill.
He replied, what did he say?
Trader P says, "I'm out of warp power. Space Pirate John, 0 units. Looks like our friend is stranded."
Okay, well, I guess we can send him some warp fuel.
50 units of warp juice transferred to Trader P. Hope that gets their engine humming again. What's next for us?
It looks like they left the sector, so they should be okay. That was quite a lot, though. Why don't we just send in 5 or something?
They did leave, so 50 was definitely enough. Next time, you can send a smaller
Alright,
amount.
well, let's hop back to sector 0 and hop up.
Back in Sector 0, the cradle of civilization. Our warp power is at 143. Want to top up while we're here?
Oh, Trader P just returned the favor. That's nice. What does he say in the message?
Trader P messaged, Space Pirate John, the 50 warp power is back with you. What a stand-up citizen of the cop.
So there's a lot of threads to pull on there, but one thing I'll say is that like routing character input, player input through the LLM context is like just a massive surface area for prompt injection attacks. So we should probably be thinking more about that. But in theory, our goal is to get this whole thing up to a point where like we can host public game servers and lots of people can play. In practice, we keep tinkering with the internals. So we probably need contributors. We made the repo open, come check it out, make PRs, download it, run it locally. I would love to see what other people do with this kind of foundation and where people push it. It's been really much more fruitful than I expected. I have learned a ton of stuff. The first meta thing that really struck me was whenever I talked to my friends who are building coding agents after starting this project, all the stuff I was thinking about for this game is the stuff they're thinking about for their sort of big heavyweight industrial agents. And that's true for the voice agents in general, but it's especially true for this sort of next generation feeling voice canvas. And 2025 really did turn out to be the year of agents. I mean, it wasn't hype. And in retrospect, I kind of think that the arguments on social media about like the definition of an agent kind of miss the point. It's not that we care exactly what an agent is, it's that we have some common ideas to figure out how to build these new patterns together, because they really do feel like new patterns. And the big one, I think a lot of us are coming around, orbiting, if you will, is that everything is a loop, plus some inference, plus some tool calls. And that's what everything we're building in 2025 looks like. Obviously, a voice agent is a loop and some inference and some tool calls. You have sort of the core voice conversation loop that's driven by input from the user, and then some inference, and then more input from the user triggers the loop again. This is the block diagram of the sort of gradient bang core. It's that voice conversation loop and the UI driver, and then a task agent that knows how to run very long running tasks and share context without blocking the voice loop. It's worth talking just really briefly about what's hard about building these loops plus inference plus tool calls. Prompting is still hard. Prompt engineering is not dead. We may call it context engineering these days for really good reasons, but the basic idea is that the LLM doesn't always do what you want it to do. And the first tool you have to get the LLM to do what you want it to do is write better prompts. We're also now building these sort of multiple inference systems, and coordinating between multiple LLMs is hard. Third, if everything is a loop, termination conditions really matter. And this is by definition hard. Hurdle and Turing and Kirby and Paris and Goodstein and all those people have something to say about that. Latency really, really matters. I'm the person who's always yelling about how I care more about TTFT than throughput. But I will say that as soon as you have a bunch of inference loops happening that have to coordinate, I now care about throughput more than I used to. And I have totally started to take for granted the fact that I have this amazing thinking sand machine at hand all the time, and now I just want it to think faster, think faster, think faster. There's also a big bucket of things I just put in the category of what the heck, LLM. Stuff goes wrong all the time, and it's really, really hard to debug. Did I find a bad spot in the latent space, or did I mess up my context management, or did I find a bug in the tool calling implementation? We do not have a surface area for debugging this new stuff that's usable at all yet. And related to that, I think building big systems with this stochastic thinking sand is different from building big systems the way we've built them for the last 75 years or so. Not completely different, but it's different enough that we really do need to figure out some new abstractions. As an example, I've been unlearning a bunch of stuff I knew about programming, and error handling is to me like a touchstone example of that. On the left is the way I've written error handling for many years, probably very familiar to all of you. I'm trying to be very precise. I'm trying to basically type the errors. I have a catch-all error block that I'm really hoping I don't land in because like who knows what to do then. On the right is like I've deleted most of the error handling code in the agent loops, and I just throw the error to the LLM context. The LLM has like a really big system instruction that has a lot of information about what it's supposed to be able to do. It has a ton of conversation or multi-turn agent context about what happened before the error. It can infer a ton of user intent. The LLM is actually a lot better at error handling than my code could ever be. And once you start to see this lens or have this lens to see these new kinds of things, I feel like you can't unsee it. And there's like a lot of examples of like, I'm just deleting code and trying to get the LLM to do that stuff. That's the guts of these agent systems. On the surface, I'm completely convinced that we're not going to program UIs at all in a couple of years. We're going to just throw structured data across the wire to a renderer and something. I don't really know what that looks like, but it's starting to sort of feel like a set of things that are coming into focus. Maybe it's a little bit like looking at that original Trade Wars terminal interface and trying to imagine the web. We've just got to build this stuff, but the software is just going to be liquid, dynamic UIs, completely different from an architectural perspective at the UI level in a couple of years. Finally, after hacking on Gradient Bang with Claude just for like the first weekend, it was clear to me that the patterns that are useful for Gradient Bang were the same patterns that we're trying to figure out how to deliver to our enterprise customers. Like more wide open canvas, but same problems we're trying to solve. And we've got a great panel of people to talk about that stuff. But before we do, I want to do a very quick speed run through some of those patterns to set the table for the panel. Pattern 1, state machine. We build a whole lot of voice agent stuff with state machines now. The goal is to give the LLM the right token at the right sub workflow part of the conversation. And I now think of these workflow conversations pretty often as a series of states, and the state transitions are an opportunity to change the system instruction, change the tools list, and do a smart compression of the context. This approach measurably improves success of voice agents. If you can build this kind of state machine from scratch in the PipeCat ecosystem, there's a pretty widely used library called PipeCat Flows. And I think isomorphically the same thing from a CS perspective is a pattern I see a lot of people building cool stuff with that I would call agent handoff. You're doing, my brain maps to state machines, other people's brains seem to map to agent handoff. I think threading state through agents that you call sequentially is the same thing as modeling a conversation as a set of states you rewrite. You should use whichever one of these maps better to your brain. You can compact the conversation in a long-running agent process, and you probably need to, because as great as current LLMs are in multi-turn contexts, they're not as great as we always want them to be. This is a parallel inference diagram of a pattern we're using a lot, not just for compacting conversations, but I think the compacted conversation is a nice example of it. We're sharing context and we're running multiple inferences. Here we have a gate in the right-hand flow that decides when we're going to trigger the compacting inference, then we compact it, and then we have an output handler that rewrites the context. Another parallel inference use, the UI driver that you saw operating just a little bit in one of those demos. Here we're actually running inference in the parallel part of the pipeline every turn, but we often don't actually want output. You can do that a bunch of different ways. You can do that with a tool called no-op. You can do that with a gate. And we're non-destructively, we're additively modifying the conversation context with the output of the UI state LLM, and we're sending that UI state over the wire. Pattern 5, and I am totally in, I have a hammer and everything looks like a nail with this pattern these days. And I'm really curious what other people are doing that looks a little bit like this. Long running asynchronous tasks. The basic idea for me here is make a tool call that starts a task, return immediately with a very static response, basically like a hard-coded success and a task ID. And then the long-running task shoves context into the voice agent context manager as it goes, for as long as it needs to operate. One thing, there's a whole bunch of interesting things to say about this. This is like multiple talks all by itself. But one thing I think is worth flagging, this feels like a kludge with today's LLMs. We are abusing the tool call and tool response mechanism. We are trying to figure out how to wrap events in user tagged messages for the multi-turn context. It works, but if you build a lot of stuff with LLMs, you develop intuitions about like when you think you're working with the grain of the model and the training data, and when you're sort of working across the grain. This very much feels like working across the grain. But with SOTA LLMs, it's so valuable to do this that we're doing it anyway. I would like to see the next generation of models trained specifically around these sort of patterns. Maybe this one, I like this one, but maybe others for very long running tasks and event coordination. Of course, you can just add a network transport to that pattern and you have another pattern which lets you run those kinds of long running tasks in sandboxes, which is useful for a bunch of reasons, including decoupling infrastructure or making your application extensible by other developers or writing and executing code safely. You can ride those tool call, tool response, and event deliveries actually on top of MCP server messages. Here's what I call the library agent. And a year ago, we would have called this a dynamic RAG system. But there's so many different kinds of retrieval augmented generation that I think we've gotten a lot more precise about how we talk about this stuff. In this case, what I think is interesting is we're using the natural language capabilities of two different LLMs to try to do pretty sophisticated content lookup. The first LLM is the voice LLM, and it has all of the conversation context. So it can use that conversation context to generate like very sophisticated natural language queries. Then we're sending that query to another LLM that has much larger world context, doesn't have the conversation context. And that lets us do things like use a long context LLM with just a really, really, really big system instruction as our RAG agent. Or we can supplement that with vector database lookups, integrations with other backend systems. And this sort of separation of concerns with natural language sort of drivers on both ends actually feels really powerful. Another version of that is the history agent. Same pattern, except we're trying to teach the natural language query LLM here domain-specific structured data stuff. In the gradient bang case, this is every single event in the universe filtered by player visibility. And it's a big, SQL database, basically. And the query LLM can do all sorts of interesting things in a loop, including things like change tool calling with Gemini 2.5 to do lots and lots of stuff to get the right answer from its natural language query and then send back a very token efficient response. So it can send just a few lines filtered that never had to go through and bloat the voice LLM context. It can even send just a natural language summary and not send structured data back at all. This has been super fun to play with. My colleague John, whose voice was in those demos, has been doing things like injecting side quests into the game. And then to solve the side quest, you have to ask a lot of questions about what's been going on elsewhere in the universe. Really creative on John's part. And again, one of those things where once you start to see that possibility, you can't work on anything else. Finally, and just for the voice agent crowd here, I've talked about this a few other places, but it's worth including in the patterns list. Using audio native LLMs for their audio processing capabilities, their audio input capabilities, but in a token efficient manner. This works really, really well with Gemini 2.5 Flash. The idea again is to leverage sort of non-blocking parallel inference. Instead of having a transcription model and a text mode LLM, we just feed audio to Gemini and let it do the conversation inference. But we don't want to leave those audio tokens in the context because it makes the context big. And even aside from making the context big, we just have benchmarks that show that audio tokens kind of pull the LLM off distribution faster than text tokens. So you're doing the transcription while the voice generation turn is happening, and then swapping out the audio tokens for text tokens every turn. Doesn't really matter if you miss a turn, like whatever, there's a lot of play here, but the idea is just to replace every audio message with a text message, and again, on our benchmarks, this like meaningfully improves success rates. So that's my speed run through 9 patterns. Without further ado, I would love to get the panel up here and talk about these things and whatever else the panelists want to talk about. While we get set, I'll just say again, go to gradientbang.com, sign up for the waitlist if you just want to play the game, because at some point we will get this thing up online for people to play. We already made t-shirts, so we have to. And go to get.new.ai if you want the source code and you want to hack on this with us. And thank you for indulging me with my side project demo. How are we doing? Are we close enough, far enough apart? How do we look?
Well, great.
Oh, thank you. So really excited to have all 3 of these people up here. I talk to all of them semi-regularly, and I know they have a lot of cool stuff to say about the patterns we're seeing and how frameworks are being built and how models are being trained and how we're doing inference. But I will let them introduce themselves, maybe starting with John.
Yeah, thanks, Ben. Great to be here. Great to see everyone. This is very exciting. I think this mic is very good. I'll keep it a little bit low. My name is John Aliotto. I work for Google Cloud. So I am a technical lead in our startups and AI group. So I have the privilege of working with founders on creating success in partnership with Google Cloud. So that's my job. It's a very cool job. And, we do the stuff like, hey, give you credits and help you get right credits. You got to work for credits. But credits is table stakes. You also get access to people and architects and training and cool stuff on Google Cloud. So if you are a startup and would like to find out what partnership with Google Cloud looks like, come hit me up after. But here tonight, I'm here to talk about sort of agents and voice and how those work together. You got a lot more faith in models than I do, but I'll tell you that right now.
We were having some email back and forth about that, so I'm going to pick up that thread.
Awesome.
Thanks, John.
I'm Arjun. I'm one of the co-founders at Cartesia. At Cartesia, we're building the future of interactive machine intelligence. So how do we think about not just models running in the cloud where you send data and you'll get a response back, but how do you actually make them more interactive, understand the world around us and respond to the world around us? I think it's going to be a pretty exciting panel discussion today. Voice clearly is, one of the primary modes of interacting. But I think just like the way that we think about the humanness of voice is something that's, slowly starting to seep into the voice agent space as well. So really excited to talk about some of that.
Hi everyone, I'm Dharani. I work at Hathora. Hathora originally started in orchestrating online multiplayer games. So our bread and butter is actually in low latency interactive experiences. And today actually on Product Hunt, we launched our models platform, which is essentially trying to democratize open source models for voice for a global market.
I will keep it with you because you had the big launch today, and we've always had a lot to talk about because there's so much overlap in network infrastructure concerns between real-time audio, video, and games. What's new about adding inference to your global network? Like, what are the new tech stack challenges?
First is wrangling with GPUs. That's been the biggest concern. But I think in general, one of the things that really got me excited about voice inference specifically is that the architecture of gaming is very similar to voice architecture. And Quinn and I have talked about this a lot. everything from like the transport layer to how you really think about scaling real-time applications versus like long-running applications is so different. Managing state is very different in real time versus, yeah. So I think there's just so many similarities, but yeah, I would say GPUs have been the hardest.
I mean, it's a good segue to talk to John because both GPU, I mean, well, maybe it's mostly TPUs are your job, but also there's a transition that all of our tech stacks are going through. I mean, so what 30 was talking about with long running processes, routing UDP packets, I often get people who build a Pipecast agent and then deploy it somewhere and it doesn't work and they're like, why? And I'm like, well, did you use Google Cloud Run, which is an awesome product, but is not going to do the things you need it to do for a voice agent? No UDP, long running stuff is hard. What are you telling people about these new use cases and how like GCP's tech stack is evolving?
Wow, that is a really, really good question.
And I didn't put that in the prep doc, so I really
totally brand new question, which is absolutely and completely fine.
It's more fun this way.
Absolutely. You warned me that you love great panels, and see, this is a meta answer because later I'm going to tell you how you can get a lot of time by having the voice agent delay its response and say, that's a really good question. What do you think about that?
You're absolutely right.
Well, this little thread goes on. No, okay. So, the speeds and feeds conversation is really interesting. It is, in all honesty, a little bit old. Like, can you build it on Google Cloud? Yeah. Can you build it on Azure? Yeah. Can you build it on AWS? Yeah. But we're adopting a lot of our products and capabilities to support AI and to move AI workloads forward more quickly. That includes Cloud Run, ton of new features in Cloud Run for AI on hosting AI app, ton of new features in GKE, so Kubernetes. We're going to see a lot more agentic workloads coming to GKE and capabilities on GKE to host these agents. Voices in your area. We do the voice models, but it's not something we would say, oh, we're going to do this particular workload, right? So that winds up being more in the network stack, in the network layer. So what we do to support that is what we've sort of been talking about is having these global VPCs that are very efficient and very high throughput and making it very easy to create those networks that work very well for these types of applications, low latency, and so the Google network is global, as you know. So once you're on the Google network, you never have to get off, which is quite extraordinary. You never have to go onto the internet backbone as long as you're going between data centers and so the networking stack that is provided there is quite good. So that piece of it is like lower level than I sort of think about things. I'm much more up in the agent stack and the platform as a service stack where we're trying to make things more efficient, token efficient. And this is what you and I have been going back and forth about because, I don't want to make this answer too long, but.
I think this is worth talking about because like I sent you some email and I was like, well, in Gradient Bang, we're doing kind of this long running task agent stuff and we're generating like this many tokens per minute per player. And you were like, don't do that.
It hurts when I go like that. Don't go like that.
I think that's a tension we see in a lot of parts of the AI stack where these new models can do amazing things, but we still have to have a lot of engineering we wrap around them or we end up in the John says don't do that category. On the other hand, like I think you were a little bit surprised that we were getting the behavior, like the good performance out of Gemini 2.5 Flash that we are, given how many like events the game server is shoving into the model context every second.
Yeah, I'm shocked. My prediction, my intuition said, with that large of a context, with that many game rules, with that many things happening on the turn, the model is going to get confused on the story. The story it's going to pull events from other turns, pull numbers from deep in the context. It's just you're pulling the conversation, the concept in so many directions. I felt like it would get confused.
We did a lot of hacking on it, and it definitely did get confused, but there were a few things we started doing that turned out to be, I think, really high leverage. One was shoving the events in from the long-running task agents to the voice agent as XML wrapped plain text. So the less JSON we feed the model, the better, loosely speaking. Now, I don't have good benchmarks for that, so I'm always careful saying that kind of thing. But like, we did a lot of experimenting, and like the model stays on the rail the way we're doing it now. It didn't before. Another thing is we hit the tools limit before we hit the sort of context coherence with mixed input, user input, and structured data events limit. And we definitely, like in the current main branch of Gradient Bang, have too many tools, and that is a problem. And so some of the thinking on those slides about how you do separation of concern is very much motivated by, we've just got to trim the tools list down.
100%. The tool space has to be orthogonal. If you have contraindicated tools, if you have a ton of tools, it's just gonna be confused. And what I see a lot of startups do is give too many constraint problems to the model, where its last resort is to hallucinate its way out of those constraint problems. So when I'm doing my prompts, I will always give it a fundamental constraint. You can't violate truth. You must tell me the truth. You must be honest. Okay, let's start there. No violations. Then I'll give it a set of constraints, and I'll say, if you need to relax one of these constraints, you may do that, but you must tell me why.
You're just doing the same natural language in the system structure.
That's right. And so instead of you must do this, must do that, because these agents these models are very rational, and they're very childlike, in my opinion. That's my opinion. They're very childlike. And so you sort of have to explain things to them. And if you give them too many, do this, don't do that, do this, don't do that, they will just give you something they think that is what you want, but it's not right. To us, it all looks very rational and easy to understand. It's like, well, you should have done this, it's obvious. But the orthogonality of tools, the separation of concerns, when I change my electrician, I don't break my plumber, right? I mean, this is, like you said, we've been doing this for 50 years in software engineering. None of that changes.
So the game in the voice in those demo clips was a Cartesia voice.
Correct.
And one of the things I've been thinking about building Gradient Bang is I really want a lot of personality in the voice compared to, say, when I'm building a call center. Yeah. I'm curious how you guys thought about the recent Sonic 3 release from that perspective. Like, how do you think about dynamic range or personality versus other attributes you're optimizing for?
Yeah, I mean, I think, one of the, hidden gems of, training these models is like, sometimes you actually don't know what you're going to get out of it, right? Like what the end model will actually be capable of doing. I think people call it different things, emergent capabilities. And, I think there's been a lot of different terms attributed to it. But I do think like fundamentally, we were really interested in how do you give people control over the voice in a way that actually, reflects the brand that they're trying to exude. Right. So if you're an enterprise trying to build for customer support, there's some level of professionalism that your agent should have. If you're building a voice agent for an NPC, it's probably something that you want to be a lot more expressive and creative. Maybe have fewer constraints, right, than you typically would give to a customer support agent. And at the end of the day, like for us, it's we're not here to pick and choose for you, right? We want to build the model so that you can customize it in the way that you like. And so, we with Sonic 3, we were thinking a lot deeper about, okay, well, how do you bring things like emotions, non-verbalisms, like, laughter, right, into the mix? Of course, this allows you to get a really nice, like, creator, like, these like expressive, experiences that you can build on top of Sonic. But on top of that, it's also like, these are great ways of adding more range, as you said, more dynamic range to like what your existing agents can do. And so, of course, there's a lot that we go into when we think about, okay, like, what are we trying to train for? How do we actually get this level of expressivity? But a lot of it is also like, how do you actually build these models from like first principles so that, your data constraint, your compute constraint, right? You still have to work under these practical limitations. We still want to be able to give, the experiences or let people control the experiences that they want to deliver as a function of these models.
I mean, can you in one model build a model that I can sort of use for an NPC that I want to be like really, really, really expressive, almost to the point of, caricature. And on the other hand, use that same model for something where the most important thing is that it doesn't do anything that's going to be so surprising.
Yeah. So, I think there's many different axes, right, that you can decompose these, voice experiences into. And I think one of the tricky things is like, how do you know what you are going to expect, right? Is there like some level of like stability or, expectation that, a model will behave in a particular way? I think that typically is done by setting temperature to 0, so that, you have a supposed guarantee, that you're not going to have a lot of variance. But what you're explaining is actually exactly what the first principle building is, right? So one of the things that we actually unlocked with Sonic 2 was this like really expressive, highly controllable voice cloning experience. So if you had a clone of like a voice actor who was super expressive, and that's the kind of voice that you wanted to use for the experience that you were building, but you also had a voice clone of like a customer support agent who's your best support agent at your call center. Very calm, doesn't get too stressed. Those people will yell at it, but I think those are the kind and what people are able to do because of that is you can customize the cloning experience. So now you can actually get both for free on the same model. So underneath the hood, it's a single model that's running, right? But you're able to control what the prompt, right, or the controls are on the model in order to deliver the experiences that you're most excited about for your customers.
And if we stay on the model training topic, I mean, it's definitely a pain point for voice use cases that models are just not as good at multi-turn as they are at single prompt inference. And you can see this in benchmarks, even controlling for context length. And I have theories about why this is, but I think I'll ask it as a 2-part question. One is this just that we don't have enough multi-turn training data? Or is there architectural stuff that we can improve that improves the multi-turn inference?
Yeah, it's a good question. I mean, context length clearly is one of the most talked about topics these days, right? You don't want to violate the context limits of your model. You don't want to make your context too large. You compress it. I actually think about architectures in a little bit of a different way. I guess to answer your question, it's both, right? Like both architectures and data result in the model that you end up getting. On the data side, of course, yes, that is part of the training recipe. But I think there's something a little bit more nuanced about architectures where we were spending a lot of our time when we were grad students, founders, which is why can't these models act more like the human brain, right? Have like memory, a fixed amount of space, and you're just like constantly recalling from that. And if you don't have an exact recollection of the token that happened 112 steps ago, you can reconstruct it. And so state-space models, which are some of the models that we pioneered during our PhDs, was actually focused on this idea of how can we be inspired by the human brain in terms of memory. Transformers, I think, have been incredibly valuable, right? They've been the backbone of modern generative AI for the last 7 or 8 years. But they also have fundamental limits, right? When it comes to things like efficiency, right? They scale quadratically in memory and speed, which means the longer your context length gets, the slower your model gets. Which is why you often have to compress your context length. Lookups become quite hard because the longer the context length is, you don't know which tokens are more relevant or less relevant. So being able to learn the process of what is important and what you can forget and being able to reconstruct later, I think that's a really interesting approach to building architectures and something we're very inspired by.
Do you think of your job in part as improving multi-turn performance specifically?
Definitely, yeah. I mean, broadly, we're really excited about everything interactive. Like multi-turn is a huge part of that. A large part of general interaction is statefulness. So historically, models have operated in this way, which is that it's in the cloud, you send context to it, it returns something, and it completely forgets about what you just sent it. That's not how the world works, right? Whether it's what we're talking about now versus what I talked about yesterday, 10 years ago, all of that actually influences the way that I'm talking to you guys today. So why can't our models be stateful? And I think that's towards the direction of actually making a lot of these models interactive. Like, of course, you need to make them efficient, right? There's, I think, 3 qualities I boil voice agents down to. The first is quality. So these are things like accuracy, naturalness, table stakes, right? The things you always measure these models on. The second is efficiency. So these are things like latency, which matters a ton for interactive applications, right? Time to first token or time to first audio is what's typically measured. And third is controllability, right? And historically, there's been like this triangle, and you're kind of trading off between the space of these. Why not make the triangle larger? You want to be able to make sure that these models can deliver the kinds of experiences that you actually care about in interactive settings.
I should say, just for context, so many LLM puns. I should say, just for context for everybody, that you guys are very well known for your voice and transcription models, but you have said publicly that's not the only thing you're building. So that's part of what was behind my question.
That's right. Yeah.
I love that answer about memory, by the way.
Yeah.
It does not look like SQL data to me. I have not been impressed by anything I've seen with memory vis-a-vis these models, because you're absolutely 100% right. It needs to look more like human memory. It needs to be reconstructed. What you think you remember didn't really happen. Every time you think about that thing, it gets reconstructed. You ask the question, what do LLM dreams look like, right? We lay down our short-term memories into long-term memories in dreams, right? If we don't even understand what human dreams are all about and how they work, let alone what these models' dreams would look like, right? So how do we do that? When I start to see things that look more like human memory, then I'll start to be impressed, not like SQL tables.
And this feels to you like something we bake into the model rather than something we build tool bridges to?
I mean, we have to build tools now because I'm not taking the over on any bet with respect to AI anymore. I'm betting under. Like, any startup could pop up tomorrow on my Twitter feed and go, we solved memory and here it is. But right now, with the technology as I understand it and the state of the art as I understand it, we absolutely everywhere have to bridge what we want with old approaches, because the old approaches are good and they still work.
I think we can pull 30 into this in a couple of ways. One is, a lot of the things that I want to do that need new kinds of memory feel like social gaming, collaborative stuff rather than the kind of business use cases that are the inflection point now, which are great. But there's like a whole nother generation of stuff we're all trying to figure out how to build. And I'm convinced we're going to live in a multi-model world for that, for a lot of reasons. How did you choose what models you started with, and where do you want to go with the inference stack?
Yeah, that's like a great question. A thought on that also is like, I'm very curious to see how like multiplayer models are also going to be. Like, instead of just one person interacting with one model, how are multiple people going to interact with the same model, and how is that model actually going to maintain context? That's just like a random thought. It's not here nor there. But in terms of what models we were really choosing to go after, I think the general market that I've noticed in voice is there's 2 types of calls that are happening, whether it's like outbound or inbound calls, and that dramatically changes the type of voice model you really care about. And so I think that definitely was a big guiding factor in terms of what types of models we were picking, in terms of like, sorry, I'm saying that many times, but it's like how expressive, like which models can be super expressive and which models are very reliable and can give you like the desired output you want. And then the other big factor I've been thinking about is, and I'm curious to get your thoughts on this as well, but it feels like the English language is quite well served. And that's amazing for US-centric or English-centric markets. But as I've been traveling and meeting a lot of developers outside of the US, it really feels like the current pricing model and the types of models that are developed are just not conducive for innovation outside of the US. And so one of my interests as well, as I was mentioning earlier, which is like democratizing voice AI, is like, how do we pick models that are cheap, affordable, reliable, and can help innovation outside of US or English-centric markets?
Yeah, no, it's a great question. I mean, I think it's very important when we're thinking about voice that we're thinking globally. Conversation is not limited to any particular region. It was just also a huge focus for us when we were releasing Sonic 3, expanding to a large number of languages. I think there's like over 42 languages now, hundreds of dialects that we support. But this was actually a fundamental question we're very interested in when we first started TTS, and started broadly working in the voice space, which is like, how do you even build the right set of tools so that it makes it easy for people from different backgrounds to be able to use these systems? How do you make pricing affordable in a way that we of course also drive down our costs, but that's also something we can pass down. And then third, and most importantly, is like going back to customization and controllability. It's the kind of experiences that you're delivering around the world are not going to be the same, right? I think there's great examples of this, right? I think a very familiar one to many is like Coca-Cola runs ads everywhere in the world. Now, how they choose to run those ads or what the billboards look like are actually not the same. Very different clientele, right? Very different like products that they're either partnering with or kind of advertise. That's actually a large part of the voice experience that we want to be able to serve, and we see our customers being able to like also want to serve, right? Because at the end of the day, it's about like how do you connect more people around the world? Like how do you give them the level of care that they deserve in order to deliver value to their users, their customers right down the line. So no, I think it's great. I mean, I think there are many differences. There's a lot of trade-offs between like cost, quality, speed, and these are important problems that we have to think about.
Going off of one of Quinn's older questions, do you think it is possible for any one model to cover all languages without any fine-tuning and get the same level of expressiveness, nuances?
I think so, but I don't think it's like on like fine tuning or on some kind of customization. Again, it's like, does the model, is it in a position where you can like do that with little amounts of data or very bespoke kinds of use cases in order to customize the model for your particular use case? I think the tricky part here is actually how do you serve that model? Is this like, are you fine tuning the full set of weights? This means you have to like serve a full set of weights every time. Not really tractable, right, to serve when you're thinking about very large models. So there's very interesting work that I think we're doing, and a lot of other folks are broadly in the research community are doing, of how do you think about serving these models at scale, but still giving these levers for folks to control and customize their models. One of the big things that we have is this like pro voice cloning offering, right, where people can upload long clips of data, and like we can deliver a custom model for them, right? So a lot of that I think will also be part of democratizing voice.
It's very, very, very interesting answer. I think you're right after a fashion. There are many concepts in various different languages and cultures for which there is no token in another language or culture. So have you ever had one of those weird experiences where the model might start speaking Korean? Or I remember one time I was talking to Gemini, this is an early version. It put a foreign word in the middle of its response to me. And I said, why'd you do that? It said, I'm sorry, let's pass that. And that response immediately became so much more interesting to me than the freaking conversation I was already having. I was like, no, explain to me why you put that there. And it's like, oh, I can't remember exactly what it was. This Burmese word, it means this, and this, and started explaining to me what it was. And I was like, you got to a place in this conversation where you found that concept was very appropriate, but did not have a token in my language, and you chose to put that there, right? So we can cover the concept space, right? But there's going to be those pieces, and it's worth investigating what those are and why those are there. And to me, those are absolutely fascinating, that this one idea would encapsulate so much of its long conversation that the model would be like, oh, you're talking about this, right? And so that to me is absolutely fascinating. So you're right. All the concepts are there. It's how do we map the tokens for the cultures and the languages to all of those concepts? Really interesting question.
The poor model speaks all the languages of the world, and it must feel very limiting to only be able to express itself to me in English. I think that's a good note to end on. We could do this forever. Thank you all, but let's all talk to each other now. We have the space till 9. Hang out. If there's pizza left, eat the pizza. And thank you for coming.
Yeah, new stuff. All this going on.
right.
Good.
That was awesome.
Congratulations on the launch.
What's interesting